Number 13 is like the example that I had. It is an ellipse, right? We saw that when we graphed it. But let's take this one down. We're still using that same property. I'm just still trying to get sine squared plus cosine squared. I'm gonna just do all the operations to get sine squared plus cosine squared, so I could change it to 1, and then I'll do all those operations on x and y and see what I get. For sine t, y equals 2 cosine t. That was weird. And then I'll just take this and this, I'll square it so that I get 16 sine squared t plus 4 cosine squared t. So I took x and y and I squared them and added them together. Note that I added them together. So I'll just write the same thing, I suppose, right below it. So this is x squared, and I'm adding, and this is y squared. Okay, but this is not 1 right now. I want to make it 1. I want to use that trig identity. So this I can divide just both of them by 16. Right? So now this is x squared divided by 16. So I write down x squared divided by 16. Hopefully that makes sense. It can be kind of confusing, so try and think about it. Remember, x is 4 sine t, so if I square it, I get 16 sine squared t. And then here I want to divide by 16 so that I can get rid of that 16, so I have a sine squared only. But to do that, I also have to divide the x squared by 16. So then it comes out to be like this. And then that goes away. Then I have sine squared plus cosine squared, because that goes away too. So that equals 1. So that means this has to equal 1, because I have x squared divided by 16. X squared divided by 16. This is getting messy. And then this is y squared divided by 16. So here's our equation. There we go. And then it said what part was traced. It was also the top half, I think. Actually, no, this one was, it went from there all the way out to 4 and then there. So it was the right side, I suppose. Or the right half is what the answers say. Alright, there you go. One more.